When I finish today's lesson, you have everything you need for Friday's test. Today is Tuesday. So today finishes up everything new. Tomorrow, I will do word problems with you. That's all it is, and questions from the study guide. Thursday, questions from the study guide, as well as your weekly homework question. And then Friday, is your test. You need to know the formulas for the test. You don't have to know them to the form of with variables. You need to make sure you know what you have to do with them. And you'll see an example of that in today's lesson, where understanding what you do is just as important as just straight memorizing something. When you're doing the study guide, and I wrote it up there in a blackish colored ink, number 28 on my study guide, you want to change it to 15 rows instead of 18 rows, and then the answer will match what I posted online. So you want to fix that, and then it'll make sense. I worked it one way and typed something else. Yes, yeah, and I wrote it right there. Number 28, 15 rows in black so it would stand out. Okay, so today you are working with what's called a geometric series. We're going to talk about the formulas. We are going to learn about your summation notation some more. Your assignment is 2, 5 to 9, 14 to 21, omit 17. 2, 5 to 9, 14 to 21, omit 17. And we'll do several of them up here together. Okay? Now, as we talk about some of the formulas that you see up here, I also wrote them for now on the backboard. So I need everybody to look on the backboard, but if they're at home, they can be looking online. So looking on the backboard, do you see the first I reminded you of the explicit formula from Friday? You have to know that one. That's the geometric explicit one. Then below that, I wrote 2 different sum formulas. It depends on what I know. Of the 2, the more important one, if you're not great at memorizing or if you're tutoring somebody that's not great at memorizing, the bottom one is the one you want them to memorize, and I'll show you why in a sec. But you see that the first of the 2 sum formulas has a G sub 1, so you know the first term, R, and N. The bottom one has a G sub 1 and R, but a G sub N. So you need to know the first term for both. You need to know R for both. But if you know N, you could use the first of the 2 sum formulas. If you know the last term, you would use the last of the 2 sum formulas. Now, humor me for one sec. Go back to the top formula again. What is the value of G sub N? What does the formula say? G sub N equals G1 times R to the N minus 1. Couldn't I take that G sub N value and plug it into that bottom formula where there's a G sub N? So if I didn't remember that middle formula with the exponent of the n, I can put the other 2 together and it would still work. I can find out the G sub n value using the other formula and then always use that last formula. Okay, and you'll see me talking about it up here as well, but I wanted you to see how they mix and match. The last thing is, to the left of my formula that I wrote there, I wrote something else. What did I do? They're both the same formula. They both mean the same thing. What did I do? Did I kind of rearrange everything? What would allow me to do that? Because the signs are also different. Could you multiply by to change your signs? -1, good. And if I multiply whatever you do to the bottom, you have to do to the top. If I multiply by -1 over -1, then that's what it looks like. I wrote that there not to confuse you, but depending on your resource will depend on the way they throw it to you. I didn't want you to think it's a different formula. It's the same one in a different format. Okay? Now, we are doing the geometric series. So yesterday with your arithmetic series, we converted our commas over to plus signs. So today we do the same thing. We're converting our commas over to plus signs to go from sequence to a series. So now here comes Teresa, And as they are working with finding the sums, she is telling everybody, she's boasting, and she's like, well, I can do this in my head because, so here's what's happening. So she was bragging to the class about this, and so then here comes Paul, and he goes, okay, so prove it. What is the sum of 1 plus 3 plus 9 plus 27 plus 81 plus 243 plus 729? So first of all, tell me what your first value is. What is your first term? 1. What is your ratio? Times 3. Good. And do you know the value of your last term? Good. Okay, so I really know everything. So now look at what Teresa says. She thinks she's really smart. 729 times 3, subtract 1. Divide by 2. Okay, let's do the next one. Stella. Stella gave the pattern 520, 80, 320, 1280, 5120. So Teresa said, okay, 5120 times 4, subtract 5, and then divide by 3. Try and come up with a rule for this. Now, Julian, 1050, 250, 1250. No problem. 1250 times 5, subtract 10, divide by 4. And last but not least, Henry, when you see that the signs are alternating, you know R is negative. So 10, negative 20, 40, negative 80, 160. And then she said, take 160 multiplied by negative 2, subtract 10, divide by negative 3. Tell me what Teresa's doing every time. Anybody brave? Go ahead. She's what? Okay, but I want to know, so like, for example, with the Stella problem, it says she took 5120. What did she do? Good. She took the last term times the ratio. So she's like she's creating her own rule. Last term times the ratio, and then she subtracted 5. What did she subtract? Oh, minus the first term, divided by, isn't the divisor each time 1 less than the ratio? Check it out. So she divided by 1 less than the ratio. Look at the backboard for me again. Look at that bottom formula. G sub n times r minus G sub 1 over r minus 1. It's the formula, okay? So some of you might get confused memorizing formulas, or somebody that you're helping might not, it just doesn't stay in their brain. There's too many letters, they'll tell you. So if you could have them tell you step by step what they need to do, then with words, sometimes it might be better than letters, okay? So again, you took your last term times your, talk to me, times your ratio, and you subtracted your, good, and you divided by 1 less than the ratio. You've just memorized the formula that you need for geometric sums. Because if I know the explicit formula, that's all I need, okay? Explicit formula and what you just spoke to me, that'll help you get through everything geometric, okay? The verbiage of what we just said is found on that same page at the very bottom, but you guys did a great job talking that through. Okay, looking up here on page 490, I want somebody then in the red, I want somebody to tell me what I did. So they gave you a pattern. There's a dot, dot, dot in between. So when there's a dot, dot, dot in between, I truly don't know without putting stuff in between what n is, correct? I could find it by keep multiplying by the ratio, but they didn't hand it to me. What do I know? Look at what I wrote in red. What is the first value representing? 1 million is the, good, the last term, times the ratio, minus first term, divided by 1 less, that formula again. So it's the same thing over and over. Okay, so practice, say it to yourself over and over if you need to, because then you're going to get really good at it. Question? Okay, we're going to do a sigma problem right here, and then we have more on a different page. This right here, the sigma, you can hear it called sigma or summation notation. Summation notation is usually the proper name because you're finding the sum. Some people call it sigma notation because they're using the Greek letter sigma. Okay, so they're interchangeable. The bottom value, your lower limit, is what you're going to plug into the variable in the problem to find your first value. The upper limit, in this case the 8, you would plug into the little formula there to find your last value. Now, to find out what r is, they actually hand it to you every time. R is always the value with the exponent, always. So look up there on C, what is r? 5. Without even working for it, it's always the value with the exponent. It's the easiest thing to shout out. If I want to know how many terms are there, the number of terms, if I said, number your paper from 1 to 8, how many questions do you have to answer? 8. So M would be 8. Now, when you create a sigma problem, you're going to start with 1. When the textbook or your ACT or your SAT starts with it, they can start with anything they want. They can start with a 0. My old resource started with negatives, like a -2 or a -7 or whatever. It doesn't matter because all you have to do is sit there and count on your fingers if you needed to, or make a list like as if you were answering those questions and they were the numbers. So on this one right here, I wrote to you that my R is 5. If I plug in 1 for k, 1 minus 1 is 0. Anything to the 0 power is 1. And if I plug in the 8 for the k, 8 minus 1 is 7, so the last term is 5 to the 7. Good? Into my formula, and that would answer the question. Question for me. Can you see that you're just extracting 3 values and the rest is formula based? Do you know how they converted 5 to the 7 times 5 to 5 to the 8? As they simplified, you didn't have to simplify it the same way. Do you know what they did? You do know this.
Actually 7 times 5 is 5 to the power of 8, and then n to the power of 0 is 1.
Good. So all they did was do the math. This has a 1 taken for granted here. Like base, you added the powers. 7 and 1 would be 8. Here, anything to the 0 power is 1. So all they did was make it really calculator ready, and that way you wouldn't have to do as many calculator strokes. Okay, next one comes with verbiage. I need you to tell me what variable it represents. So it says a sequence with 9 terms. What does 9 go in for? N, good. Common ratio of 2, somebody else, yell it out. R, everybody should have that one. And the first term is 3. G1 or A1 is 3. Good job. I have enough to find the sum. I plug it in. If it seems like it's monotonous and it's the same thing over and over, it's the same thing over and over. Question? Okay, on this frame before I switch, look at this pattern right here. So in one of the classes, somebody said 1 looks like it's out of place there. So first let's talk about the pattern, and then I'll tell you what it really is in disguise, or you'll tell me what it really is in disguise. So your first term is 1. Would you agree? And then what are you multiplying by? What do you multiply 1 by to get 2? 2. So R is 2. How many terms do you see there? 5. And the value of your last term is 2 to the 4th or 16. Okay. So 1 looks out of place, but it's really not, because what is it really coming from? Do you know? Good. That's really 2 to the 0 power, because anything to the 0 power is 1. So all they're doing is upping the exponent by 1 each time, because they're multiplying by 2. Okay? If I ever asked you to find a sum, and there's not a lot of values there, but that's all I'm asking you to do is find the sum, it wouldn't be unreasonable for you to list out, oh, I can do 1 plus 2 plus 4 plus 8 plus 16 and add it up. That's not cheating. The problem comes is if my pattern goes all the way to 2 to the 100th power and you think you're going to do that. You won't have enough time. Okay? Go ahead. 31. Oh, 2 to the 5 minus 1 over 2 minus 1. Question, anybody? Okay, we don't have to do proofs in here. That's a geometry thing. But this is an algebraic proof. But what's neat about algebraic proofs is that what they're writing next to it is just like what you would say to me, the action that you did to get from one step to the other. So we're just going to talk about this in the day. I would have had my students prove this, go from one to the other. Now I'm just showing you this. This is in your textbook. That's why you see it in the spiral right here. But I want to go through from one form to the other so you can see how the two formulas fit together. So, do you remember the explicit formula? Look where I'm pointing, where I drew the line. Okay, so with that being said, starting with this formula right here, G sub n times r minus G sub 1 over r minus 1, the one that we keep doing over and over again. What could I plug in for that G sub n? What is the value of G sub n? Good, G sub 1 times r to the n minus 1. So if I took that G sub n and actually replaced it with what you just said, then here is your new format. Okay, that's a substitution. And it says what I subbed in. Now, let's see what I have up here. G1 r to the n minus 1 times r. The minus G sub 1 is not going to change. Remember, the r has a 1 power. Like base multiplication, you add your exponents, right? So negative and positive 1 are going to cancel. That leaves you with the r to the n that's right here. And then all they did was they factored out the G sub 1. Okay? So they went from one form to the other just by doing some basic steps, substitution and multiplication, and then factoring. And again, that's in your textbook. Okay, we are going to work with sigma. So I kind of put spots there. Yours, you're not going to have boxes, but I put them there so you could picture what we're going to be filling in. So the first problem here, number 7, says we want to rewrite each series using summation notation. So on your test answer column, you're going to see this. And then you're going to fill in everything else. So in order to start the problem, I need to know what my first term is, I need to know what r is, and I need to know how many terms there are. So somebody tell me the value of my first term. Good. Somebody tell me, what do you do to 4 to get 12? Multiply by 3. And how many terms are there? 5. I have everything I need to answer the question. Okay. So when you create your own summation notation, you're going to start with I equals or N equals. I saw on your resource J equals, but you want to start with 1. They can start, like I told you before, with anything they want. If you start with 1, then your upper limit is going to be what you just wrote N is. What did I say N is? 5. Good. Now, next to it, we're putting the explicit formula. The explicit formula is a sub 1 times r to the n minus 1 power. What is a sub 1? 4. What is r? What is r? 3. And since I have an I there, I might put an I minus 1. You could put an n minus 1. Just have them match out. Done. That's it. That is summation notation. So look at the next one that I filled in for you already. 1 is obvious. Number of terms you can count is 7. 64 is the first term. What do you do to 64 to get 32? Half it, and then there's my I minus 1 power. So that's just a matter of practicing. So start with 1, end with the n, explicit formula, summation notation. Just sounds like it's going to be harder than it is. Go ahead. Or I've seen it with all different variables. So if that's an I down there, you'll usually see an I up there. If they start with an n equals, then it'll be an n. Because this is telling you what to start with. So if I want to find the value of the first term, you're going to replace I with 1. And if you want to find the value of the second term, you replace I with 2. All the way up to 7, and that would give me the value of the last term. So not that, go ahead.
So is it always equal 1?
The denominator, the bottom number, the lower limit, you want, it's not saying I equals 1 really, it's saying you start with the value 1. So yeah, but yes, technically what you're asking, yes. When you create it, it will be 1. When anybody else, the resource creates it, it can be anything they want. It could be a 0, which you're going to see in a few minutes. It could be a -2. And so then you would have to count on your fingers or whatever to figure out how many terms there are. Go ahead. Yes, go ahead. As long as you promise to stay awake when you come back. Okay. Okay, next. Given the sigma, now we're going to compute. So backwards, forwards. This is really easy, though. Everything is yelling at you right here. Now, anybody brave tell me how I could get the value of my first term? What do you think I'm going to plug in? The lower limit, 1. You plug it in for I. What is 1 minus 1? Good. And what is anything to the 0 power? Good. Very good. Okay. So you just told me that my first term is 1. And R is always the value with the exponent. So what is R? Very good. And then how many terms are there? 4. Very good. And if I wanted the value of my fourth term, I could replace the I with 4. So 4 minus 1 is 3. So that's 6 cubed, or is that like 216 or something? Somebody spot check me. Is that enough to find a sum? Anybody question before I tap? Okay. And then again, once you know everything, you can use either sum formula. That's up to you. Okay, now look at B. What's different in B? I know the values have changed, but what is extra in B? Okay, so the exponent only has an I and then something else. Okay, I'll take that in a sec. Let me finish this and then I'll go back to you. So it starts with I equals 0, so that's another different piece of it. And then one more thing. Yeah, there's like a 10 out in front of it. So there's all these extra pieces here that we didn't do on the first one. It's the same kind of problem, but it's a variation. So in order to find the first value, you're going to take the 0 and plug it in for I. What is anything to the 0 power? Very good. R is always the value with the exponent. What is R? 3. Good. Now, number of terms. No. 5. How come? Because you have to include 0. So here we go. 0, 1, 2, 3, 4. Okay? So that's your 5 value. So that's where you have to be extra careful. If I really wanted to find out the value of the last term, then I could plug in 4 to the I. Okay? Now, this is telling me that, I'm going to cover up the 10 for a sec. Find the sum using your formula and then multiply by 10. Yeah, exactly. So, sorry about the writing over, but that's what you're doing. So there's the 10. There's what we did, 3 to the 5th minus 1 over 3 minus 1 to get your answer. Now, back to the other one. Talk to me.
What is row 6 cubed? What is that?
The 6 cubed would have been the value of the last term. Because if you put 4 in for the I, 4 minus 1 is 3.
Oh, that's like, I can't tell.
Oh, G sub n. You couldn't tell my scribble. You were just being nice. So C, I'm not going to work. Go ahead. Oh, it does, remember I told you yesterday that I'll interchange them. Some resources will use A, some will use G, and I go back and forth. I learned A, and I did A for 30-some years, and then Carnegie did G. So the A is embedded in that brain a little deeper than the G. Okay, on the next one. After you got your sum, tell me what you're going to multiply by. On C. 6, good. How many terms would you tell me there are? Very good. What is your ratio? 1/3. Good. So if you can, again, talk the body parts, then you can do the problem. Okay? So from your homework, compute means that you want to find that answer. You want to find the sum. Think about the word computation or something like that. So when we compute, we're basically finding the sum. So this is 5 on the homework. And so the first thing I did was I had ready for you is my R value. Is that a surprise? R is 2. Then I wrote down the value of my first term is 1. Do you agree with me? Yes. Then I wrote down the value of my last term is 128. So the subscript with that G there is an 8. How come? Why is that subscript an 8? Do you know? You have to count the 0. So there's 8 terms. That's yelling at me. Mrs. Stewart, there's 8 terms. That's what N is. And the value of the 8th term is 128. So plugging it in, you could use either formula. It didn't matter which one, and that would answer your question. So you could use the formula with the A sub n, or if you like the n formula better, then go for it. Question? So the people that are going to do poorly on my test are the people that don't want to memorize the formulas and learn how to use them. If you practice this, it's just like one thing after the other of the same kind of thing. And I chose to do this last so that it's still fresh in your head come the exam, because there's more formulas to memorize in this than there was anything else that we've done recently. Okay, on my number 14, I rewrote it big over there in blue as well. Please tell me how many terms there are. 6, right? And what is your ratio? What is the ratio? 3. How do I know? It's the one with the exponent. I keep saying that because sometimes there'll be an extra value. So, do you remember how in that previous problem there was a number out in front? And with that number out in front, was it on a different frame? Yeah. With the number out in front, here, this was also like an I minus 1, I think, or n minus 1 up there. So this one has the number here instead of over here, and then it's just a plain old I. Ultimately, when you finish, you will get the same end result. However, the workings of it, you would end up with a different first term. You will end up with different values you're going to use, but the sum will be the same. It's just that here, you're going to multiply by 2 early on. The other kind, you would have multiplied by the 2 at the end. Okay? But it would give you the same end result. I didn't want you to think that it was different or tricky. So, if I know that my first term is 2, and I know that my R is 3, I know N is 6, and if I want to find the value of the last term, what do I plug in where? The I for the 5 for the I. So that gave me 3 to the 5th, which is 243 times 2, whatever that gives you, and then you could use either formula. Question? Okay, we'll do the couple word problems next, and then I'm done, and I'll give you back your test. How much time do I have? 6 minutes. Okay, here is my story, maybe. Thinking. Okay. A soccer tournament has 64 participating teams, period. In the first round of the tournament, 32 games are played. The winning team from each game moving on to the next round. In the second round, 16 games are played, with the winning team from each game moving on to the next round. This pattern continues until one team emerges as the winner of the tournament. How many games are played in the tournament to determine the winner? So I might be the treasurer of the soccer association. I've got to get refs for all these games. I need to know how many refs I need, so that I make sure we have enough money in the budget to cover it. So that's what this would be. That would be a situation like that. So, am I even using the 64? I hear yes, and I see no. You're actually not. Everything else is about your teams or your games. Do you see how it's 32 games, 16 games? Everything's talking about the games. So you're starting with 32 games. That is your first term. What do you do to 32 to get 16? Multiply by 1/2. Good, so we know R. We know the first term. Now, it goes down to how many games? 1, it said so. Okay. Then, if you wanted, you could do your basic math counting. So starting with 32, then 16, help me. 8, 4, 2, 1. So that's 6 altogether. That's your N is 6 to get there. If I have all that information, could I find the sum? Yes. Okay, so I'm going to tap this just so you can see. Now, if I totally blanked out on the test, this is only 6 values. Couldn't I take 32 plus 16 plus 8 plus 4 plus 2 plus 1 and add it all up? Probably what the person in charge of that committee is doing. That would give me how many refs I need as well. Okay? So keep in mind it does the same thing. If there's only 6 values, that's not cheating, or you can call it legal cheating, because it's still giving you the sum, it's just not using a formula. And I'm going to scoot it so that I can have you set up the next one. You guys should be able to do the math there. Serena paid $8,700 to attend college her freshman year, and she found that the cost is going to increase by 8%. Stop. Is her R going to be 0.08 or 1.08? 1.08. If it decreased, if the governor said, I'm going to lower it by 8%, then what would it have been? 0.92, you would take away the 8% from 100%. Okay? Now, continuing on, she stays there for 6 years. So maybe she failed some classes, maybe she dropped some classes, maybe she has to pay her way and she can't take a full load. There's lots of reasons. So here's the information we know. Would you agree with my information that I typed there? Okay, so the first thing I did for you with my math is I found the value of the last term. So my last term, so the last year there is costing her $12,000 and change. That's just her last year. Is that the sum of all the years? No. What would you do then? Plug it in. So to finish it off, here is the plug-in to give you how much the college tuition was going to cost over the 6 years. Okay, so I'm going to call you up to pick up your papers. Come on down, please. I'll leave this here, and I'm doing this staying connected so I don't forget to save. So come on down when I call your name, please, Lauren and William. You're there. Shayla. No. That's okay. Taylor. Mia. Lael. Sydney. Gavin. Logan. Adam. Paige. Jack. Elena. Chris. Ethan. Adam. Ariana. Jackson. Don't step on the, just walk around, please. Colton, Colden, Delaney, Ben, Andy,
That's fine.